So we've got the new pinion gear, we've got the old pinion gear, we've got the crush sleeve, the old crush sleeve, it's not reusable. We've got the old pinion bearing, we need to pull that off. And the reason we need to pull that off is in between the pinion bearing and the pinion gear is supposed to be a shim called a pinion depth shim. And the pinion depth shim controls how far back or how far forward in the differential housing the pinion gear sits. And that affects the contact pattern of where the pinion gear teeth contact the ring gear teeth on acceleration and deceleration. And if that depth is not correct, then you'll have an incorrect contact pattern, which can cause noises to occur on the acceleration or deceleration or both. It can also cause vibrations to occur. So we are going to set up a bearing splitter on this pinion bearing and remove the pinion bearing next and see what shim should go underneath it. Okay, here we are at the hydraulic press. You're going to need a hydraulic press like this, or similar, of course, to remove and install a lot of bearings on different rear differentials and front differentials. We are going to remove this pinion bearing right here with a device called a bearing splitter. So this bearing splitter has a kind of an angled surface, and then has a flat surface. You can use either side depending on how well you can get in underneath the inner race of that pinion bearing. You just put it over the gear like that. You finger tighten. You do not need to wrench tighten these nuts on these threaded shafts here. You're just going to tighten those up to where it's got a good bite underneath the inner race of that pinion bearing. And the reason you want to be real careful not to ruin this bearing is that shim is a selectable shim. And just because you put a shim underneath it doesn't mean it's the right shim. So chances are you're going to have to pull this bearing off again, even if it's the new bearing that you're using. You may have several times that you've got to remove that bearing and press it back on to change the pinion depth shim. And that's an expensive thing if you ruin the bearing every time. So a bearing splitter will let you get in underneath the bearing and pull it out. Now, on this hydraulic press, we've got this blue bridge piece right here that can go up or down. And then we've got these silver bridge bars that span across the blue bridge, and they have a little cutout in them. So we're going to set the bearing splitter down in. But one mistake a lot of technicians make with this bearing splitter style on this type of a hydraulic press is they put the threaded shafts bridging these two little silver bridge bars. And that way when you push down with the hydraulic press, all the force is on that threaded shaft and it ends up bending the shaft. And so you end up with the threaded shaft is all bent. Well, if you would just rotate the bearing splitter a quarter turn and let the heavy duty bearing splitter surface bridge that gap, then it does not bend the threaded shaft. So now I'm going to come in with the hydraulic press and just push down on this old pinion gear and remove the pinion bearing. And once again, the purpose for that is to get to the shim underneath it to see what shim was there. Now that does not mean that's the correct shim for this new set of gears. Most likely it's not, but it'll at least give us an idea of what shim was there before, so that that'll put us at least in the ballpark of where we need to be. We would hope if it was set up correctly last time. So I have an air-powered pump here on this jack, or on this hydraulic press. So it comes down. I don't have to pump a stupid ram type pump, but I'm going to hang on underneath and push down at the same time with the hydraulic press. There we go. And the pinion drops down. The bearing stays with the bearing splitter. The bearing did not get damaged at all. And right here on the pinion gear itself is a pinion shim. Man, it is in rough shape. It is bent, beat up. But that's the shim that we're looking for. The number of notches in this little round shim is supposed to tell us its thickness, but I've got a digital caliper we can measure the thickness also. So on the new pinion bearing or pinion gear, we're going to put a shim. It's not necessarily going to be this one, and then press the bearing back on, and then put the whole thing together and see what the contact pattern tells us once we've got it set up. And if the pattern tells us this shim is wrong, then we've got to take the whole thing apart again and change the shim, either thicker or thinner, based on what the contact pattern tells us. So now we're going to go over to the differential housing and the other pinion gear and see if we can decide what to do for a shim on the new pinion gear. Okay, we've got the new pinion gear right here, and we just removed the old pinion gear depth shim using the hydraulic press. I measured it with a digital caliper that we've got here, and it's 28 thousandths of an inch thick. Since this shim has these two little notches in it, I happen to know that that's an original GM shim that came notched like that. I suspect that that's the original shim that came with the car all those many years ago. And it's 28 thousandths of an inch thick. Now, since we need some sort of a starting point for a shim to go on before we put the new bearing on, I'm going to go with that 28 thousandths shim thickness. I'm not going to reuse that old shim because it's too beat up. But with the new overhaul kit that we have for this differential, it came with a big selection of shims. And so I've got a 16 thousandths and a 13, 10, another 13, 19, and two 20s that you can stack together and come up with different thicknesses. Well, I'm going to put the 13 and the 16 together. That'll equal 29. And I'm going to put that on here as our starting point. I believe the original factory shim was 28, but we're going to start with 29 and see what we come up with. Let's see, I do have a 19, it still wouldn't give us 28. I don't have a combination of new shims that will equal 28, so I've only got 29. I do have some old original GM shims here at the school that we could use if necessary, but let's start with this 29. We're going to take the new pinion bearing and we're going to press it onto the pinion gear. There's a special service tool from General Motors. It's basically a pipe of a certain diameter, and that pipe is going to be used to press the pinion bearing down snugly, firmly against the shim here, and then we can put the pinion in the differential housing once we put the pinion bearing cups back in. So let's take this over to the Arbor Press and we'll press this on. Okay, we're here at the Arbor Press. An Arbor Press is not hydraulic. It has a handle that you pull down on, and there's a gear with gear reduction that will push down on this ram that will push the tube to push the bearing down onto the pinion. This is a 1.5 ton or 3,000 pound Arbor Press, which means if you pull down, I believe with 150 pounds of force here, you'll get 3,000 pounds of force on the press arm here. And I like to use the Arbor Press to install these rather than a hydraulic press, because with a hydraulic press you cannot feel how the bearing feels as it goes on. You can't tell if it's binding up or about to break, where on the Arbor Press you can feel it going on. And of course you can watch it also, but sometimes you'll feel it bind up and you'll want to stop and take it back off and just make sure that everything's going okay. So we're going to zoom in just a little bit here so you can see the bearing get pressed on just with the Arbor Press. It's just going to be me pulling down on this lever here. So here we go. Okay, we're there. We've got the bearing pressed down all the way against the shims that we just stuck on. We have no gap there. We've got the shim installed. Oh, by the way, I did put some lubricant on the inside of the inner bearing race and on the pinion shaft there. You never want to press one of these on dry. You'll really get them to bind up. So we are also going to lubricate the bearing when we install it in the differential housing. You never want to put dry bearings in an axle. You always want to lubricate them. It will affect the bearing preload measurement. I've discovered in the classes that I've taught that if you put one of these together dry and measure the bearing preload and then put some oil on it and remeasure it, it drops by about 5 inch-pounds, the rotational torque of a dry bearing versus a lubricated bearing. So always lubricate them, and of course the bearing will last longer if it's lubricated on initial assembly also. So now we're going to take this over to the differential housing. We're going to install the differential housing pinion bearing cups that we drove out with the brass drift, and then we'll go through the installation, the initial trial installation procedure for this pinion to determine if that shim pack that we just installed is the correct thickness of shim to get the pinion depth correct for our contact pattern. Okay, the next thing we need to do now is install the pinion bearing cups or races into the differential housing, because we drove the old ones out, and we're putting new ones in. So I've lubricated the bore that the bearing is going to go in, and I've got this bearing lubricated externally. I'm just going to line that up by sight evenly there, and then we've got a special bearing driver. Lift this up a little bit so you can see. It's just a handle with round disc that we use to drive that bearing cup in. I've got a selection of these discs, sometimes called replacers, that you can use to drive bearings, bearing cups in and out of wherever they are. So I really like to press these in when possible with the Arbor Press, but the shape of this housing doesn't allow it to fit in my Arbor Press very well, and I do not like to use the hydraulic press on these because you can't tell if it's binding. So we're going to go to the swinging press here, which I really don't like to use, but don't have any choice in this case. The problem with hitting this with a hammer to drive it in is it can get off, it can get tilted off to one side and not going smoothly. So we want to try to drive this down as even as possible. I'm not down all the way yet, and how do you tell if you're down all the way? As you're hitting this tool, the sound will change. It'll get much louder when it bottoms out in the bore. So listen as I get there. Right there. See how the sound changed? Now I know that it's bottomed out, and the bearing cup is down in the housing as deep as it should be, so that when we put the pinion gear down in with its bearings and tighten the pinion nut, we're not also pulling pinion bearing races down as far as they should already be. So now we're going to do the other side here. I'm going to put some axle oil in the housing and coat the bearing externally with the oil. Get it lined up, and we'll do the same thing. We'll drive it in with the appropriately sized driver here. Almost there. Right there. The sound changed. We bottomed out. It's down in as far as it should be. So we've got those bearings ready for the pinion gear itself now to come in and go right down into that bearing cup that we just installed for the rest of the reassembly procedure. Now that shim that we put under the bearing, as you can imagine here, is going to lift this pinion gear up or let it go down depending on how thick or thin that shim is. And so when we tighten the pinion nut on the other side and get the bearing preload set correctly, that pinion height is adjusted by that shim. So on the initial installation, we are not going to install the crush sleeve. The crush sleeve is a one-time use sleeve. It physically crushes and gets smaller when you install it for the final time, because you're tightening the other bearing down onto it along with the pinion flange. And this helps transfer the torque of the nut through the flange to the inner bearings, so that we've got something pressing out from inward out besides outward in on these bearings. This pinion will physically stretch just a tiny bit as we preload these bearings. And this crush sleeve gets crushed during that process. But since we only have one crush sleeve, we don't want to put it in yet because we're not sure if those shims that I put in are the correct shims to have. So we're going to assemble it without the crush sleeve first, and then run a contact pattern check and see if the pattern tells us that we need to change the pinion depth shim. So the next thing I'm going to do is lubricate both of these bearings, put the pinion in the housing, get the pinion flange on, and preload these bearings so that we can get the pinion all installed so that we can put the differential case in, set the backlash, set the preload, and run the contact pattern check. It's a lot of work. And because it's so much work, it's something that most technicians don't do. They'll just throw in the old shims, set the backlash, and call it good. But if you want to be precise and get that contact pattern right where it should be and avoid gear noises as you drive down the road, you must go through this process that can be rather time consuming, which if you're paid by the hour, that's not a huge deal, but if you're paid flat rate and your time has expired, the more time you spend on it, the more time the money you're losing that you could have been working on something else. So it is a tough thing to do. I tell my students all the time that any slob in a wrinkly t-shirt can take one of these apart, but it takes someone with skill to put these things back together properly. So we will proceed with the installation of the pinion.